Will proceed in innovative approach in calculus, Taylor series, Maclaurin series, multivariable. Multivariable Taylor series, Maclaurin series that is generally not available anywhere. I mean, anyone can write multivariable equation of the Taylor series, but the proof for the multivariable Taylor series is very, very difficult, and whatever is very difficult, generally, whatever is very difficult, generally people avoid it. So idea is that everyone should understand who is trying to understand. So that is the concept. If someone is trying to understand, then he should be able to understand. Now, this Taylor series and Maclaurin series, as far as single variable is concerned, I believe it is all right. As far as single variable is concerned, it is all right. Means the proof what we have placed, it is understandable. But whatever the proof, it is available for multivariable. Multivariable. What is the Taylor polynomial approximation? Taylor polynomial approximation for the multivariable case for any algebraic equation. I believe it is available. fxy equal to a0, that is the beginning one, plus, okay, plus dy by dx into x, dy by dx into x plus dy, I'm sorry, it is fxy. Consider fxy equal to z, fxy equal to z, then fxy equal to a0 plus dz by dx into x plus dz by dy into y. This is the first order polynomial approximation, plus 1 by factorial of 2 d2z by dx square into x square plus dz by dx into dz by dy plus 1 by factorial of 2 d2z by dy square into y square. Okay, plus, now this is the second order. Third order is 1 by factorial of 3 d3z by dx square x to the power 3. Okay, plus, I believe, plus 1 by factorial of 2 d2z by dx square dz by dy dz by dy x square into y plus 1 by factorial of 2 d2z by dy square dz by dx x y x into y square plus 1 by factorial of 3 d3z by dy cube into y to the power 3 plus this is third order, like that up to nth order. This is the polynomial, this is the polynomial approximation as far as multivariate in Taylor series is concerned. Now I am not differentiating Taylor series and Maclaurin series because I am not going to put x minus x0 x minus, that is the only difference. In Maclaurin series, the point at which the dy by dx is calculated or dz by dx dz by dy is calculated is 0. Okay, whereas in Taylor series it is differentiated at point x0 y0. Okay, so in multivariable case, if I am saying the first order derivative fxy multivariable polynomial approximation of any algebraic equation. If I have fxy algebraic equation, okay, I have very big algebraic equation. I'll show. Okay, what is this? This is my algebraic equation. Okay, can someone believe this is an algebraic equation? Indeed, it is an algebraic equation. It is very big. This algebraic equation is very big. What is inside this algebraic equation? You cannot see it. Okay, this algebraic equation, you cannot see it. What is inside this algebraic equation is? Inside this algebraic equation is multivariate algebra. What is multivariate algebra? Inside this ball. Okay, it's not a ball. Anyway, so what is inside in this ball? Then multivariate algebra is sine x into cos y plus tan y into e to the power y into 1 by log x. I mean all the jumbled thing that is available in algebra, that is equation of x and y both multivariate. That is fxy. Fxy, small f braces x comma y braces close. Fxy. Fxy equal to sin x into cos y plus tan square x by e to the power y plus log x into x to the power 5, something like that. I have kept everything inside it. It is a, which is very heavy. It is a like a black box. Now, can you tell me what it is? Can you tell me what it is? You have to tell me what it is. I am carrying this algebraic equation in my hand and I'm asking anyone, can you tell me what it is? Or someone is asking what it is. You have to guess. I cannot guess. I cannot guess. I can see outside, but what is inside, I cannot guess. You have to guess. So if a person is carrying algebraic equation and other person is trying to guess it, then how he would guess? Okay, if it is a single variable, if it is a single variable algebra, then other person would say, can you tell me the value of this, the value of algebra when time when x equal to 0. Okay, this is the value of algebra when x equal to 0. What is the value of algebra when dy, what is dy by dx, dfx by dx when x is 0, d2 by dx square when x is 0, d3 by dx cube when x is 0. That you can give him because you are hiding the algebra only, but you are revealing the truth. This is the Taylor series. If person is getting x equal to 0, what is fx? And dy by dx when x equal to 0, d2y by dx square where y equal to fx. If he is getting all the order of derivative, then he can assemble in a Taylor series where fx equal to a0 that is the value of fx when x is 0, dy by dx into x plus 1 by factorial up to d2y by dx square into x square plus 1 by factorial of 3 d3y by dx cube into x to the power 3. Okay. Similar way, now question is arising that if someone is carrying a big algebraic equation multivariable in x and y form, then other person who is trying to approximate, this is called polynomial approximation. If he is trying to approximate this algebraic equation, then what question he is going to fire on the person? I am the person, I am carrying this. What question he is going to fire on me so that he would assemble it and he can make a approximation of this algebra as per the polynomial approximation is concerned, multivariable, that is under question. Okay, so there are many proof I believe I have quoted. What is the multivariable polynomial approximation? That is a0 plus dy by dx into dz by dx, fxy is z, dz by dx into x plus dz by dy into y. This is first order. Second order is 1 by factorial up to d2z by dx square, d2z by dx square x square plus 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 dz by dx into dz by dy. If I had forgotten this, dz by dx into dz by dy x y plus 1 by a square 1 by factorial of 2 d2z by dy square y square. This is second order. Third order is 1 by factorial of 3 d3z by dx cube x to the power 3 plus 1 by factorial of 2 d2z by dx square d2z by dx square into dz by dy x square into y plus 1 by factorial plus 1 by factorial of 2 dz by dx into d2z by dy square xy square plus 1 by factorial of 2 d2z by dy square into y square. This is the second order derivative. Plus 1 by factorial of 3 d3z by dx square x to the power 3. So on. Okay. This is the polynomial approximation of the multivariable. But how I can bring this? Now, what question the person is trying to emulate, person is trying to simulate, person is trying to copy this algebraic equation, what question he is going to fire on me? What is the value of your fxy when x equal to 0, y equal to 0? Okay, when x equal to 0, y equal to 0, because it is fxy, z. Dependent component is z and independent component is xy plane or x-axis, y-axis. In two dimension, independent component was x-axis and dependent component was y-axis. Now here z-axis. So what is your value of fxy when x equal to 0, y equal to 0? At the origin, what is the height? Okay, got it. What is dz by dx and dz by dy when dz by dy when x equal to 0 and y equal to 0? What is d2z by dx square, d2y by d2z by dy square? What is d2z by dx square? What is d2z by dy square? Anyway, I know dz by dx, dz by dy when x equal to 0 and y equal to 0. What is d3z by dx cube? What is d3z by dy cube? Anyway, other I know. So if I know all these kind of things, then I can recreate any hidden algebraic equation in terms of polynomial approximation. Polynomial approximation is highly usable, that we will see, because it simplifies things and at the end it is approximation. At the end it is approximation. So integral calculus, which is very difficult to calculate, someone can go for polynomial approximation and then he can calculate the integration and to some order, 6 order, 7 order, 10 order, whatever it is, and then some very near about result he may get. That is the scenario. But how to prove it? That is a big question, and proof is available, but at least for people who are very straightforward in their life and they don't want to kind of do too much thing, too much, they don't want to face unnecessary difficulty anyway no one can avoid, but unnecessary difficulty, how someone can see through. Now question arises is what we are trying to do. What is the single variable Taylor series? Taylor series, Maclaurin series dy by dx we calculate then for the two dimensions. dy by dx, if I am asking, then it is x equal to 0. Whereas in Taylor series dy by dx I am asking when x equal to x0. x0 is some constant. That is the only difference. One is at x equal to 0 and one is at x equal to x0, some constant value. That is Taylor series, that is Maclaurin series is a special case of a Taylor series. Okay, so now I am kind of, if I have a single variable, then what is polynomial approximation? Polynomial and leave the a0 fundamental. The first part, when we see the polynomial approximation, the first one fx equal to a0 plus a1 plus dy by dx into x. That is the first order. Leave the second order, third order onward. Leave the a0. Now fxy equal to fx equal to dy by dx x, where dy by dx is calculated at x equal to 0. If it is calculated at x equal to x0, then it becomes fxy minus y0 equal to dy by dx calculated at x equal to x0 in bracket x minus x0. This is Taylor series. Otherwise, if it is calculated at origin x equal to 0, then it is fx minus y0 or fx equal to a0 plus dy by dx calculated at x equal to 0 into x. Anyway, I know that single variable is y equal to dy by dx calculated at x equal to 0 into x. Very well. What about what about multivariable? Fxy equal to what? First order only I am asking. What is fxy equal to? Fxy equal to what? Okay. Now let's see what it is. Okay. I have a straight line. I have a straight line. And this is x-axis. This is x-axis. Now can someone tell me what is this height at point x? This is point x. Or if this is point x, this is x-axis. This is any point x. At this point, what is this height? What is the y? Okay. Now someone would say this y, the y is nothing but sine, this is angle theta, then sine theta equal to y by hypotenuse, or tan theta equal to y by x. So tan theta equal to y by x, y equal to x tan theta. Very perfect. Okay. What is tan theta? What is tan theta? Y equal to tan theta into x. What is tan theta? Tan theta is nothing but y by x. I can replace there, right? Y by x into x is y. What is y by x? Okay. If it is a straight line, then y by x is perfect. But if it is not a straight line, then what about, okay, leave it. Okay, y by x. So y equal to, at any moment, y equal to y by x into x. Y by x is division. In calculus, it will come as differentiation. So y equal to dy by dx into x, or y equal to y by x into x. What is y by x? If this is y, this is x, what is y by x? This is also called slope. This is also called slope or derivative, gradient, whatever comes to the mind. Now, okay, this is the curve. This is a curve. At this moment, this is x-axis. Up, 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 up. Okay, this this point is x. If that is x, then this height is y. I'm talking about this point where it point is x comma y. Height is y and here it is x. Okay, what is y? What is y? Okay, then someone would say, ask, what is the slope? At that point, what is the slope? Slope at any point is dy by dx. Slope at any point is dy by dx. So at this point, what is dy by dx? Okay, dy by dx will be infinite at this point though. Anyway, any point. If I am calculating any point, consider this point. Now dy by dx has some value. What is dy by dx? Then y equal to dy by dx into x. Dy by dx into x. That is the y. That is the equation of a line. So if I am asking what is equation of a line here, if this is the line, if this is the line here, tangent line, what is equation of this line? Then someone would say, calculate the dy by dx. At that moment, what is the slope? Whatever the slope is, that is dy by dx. Y equal to dy by dx into x. That is the equation of line at that moment. Later we will see delta y equal to dy by dx into delta x, probably in the product rule of the calculus. That we will proceed in innovative approach, whatever it is. Any moment, what is dy by dx? If I know any moment what is the slope, then y equal to dy by dx into x. That is the instantaneous line at that point. What is line equation here? Dy by dx into x. Dy by dx into x. So it is making so many lines at every point. Okay. Now, if I consider this is x-axis and this is the slope. What is equation of this line is? Equation of this line is dy by dx, that is slope of this line, into x. If dy by dx is 1, means it is 45 degree, then y equal to x. That is the equation of the line. So whatever the slope is, how much it is changing, dy by dx into x gives the equation of line. Dy by dx is constant. It is not variable everywhere. So every point on this line, dy by dx is constant. If I take any point on this line, dy by dx is constant. Dy by dx into x is the equation of line. It's a straight line. Now I found the equation of a straight line or any point tangent to any curve. That line is y equal to dy by dx into x. If this line is passing through any point x0, y0, then it is y minus y0 equal to dy by dx x minus x0. If this line is intercepting x-axis at x0, then equation is y equal to dy by dx x minus x0. If this line is intercepting y-axis at y0, then it is y minus y0 equal to dy by dx into x. If this line is passing through a point x0, y0, then it is y minus y0 equal to m dy by dx x minus x0. So since it is intercepting x-axis at x0, y is 0 at that time. So general equation is y minus y0 equal to dy by dx x minus x0. There y0 is 0. So y equal to dy by dx x minus x0. If this line is intercepting, this is y-axis, this is x-axis. Consider this was the line. I shifted line little up. Now it is intersecting y-axis at y0. At that moment x0 is 0. Y minus y0 equal to dy by dx x minus x0 is the normal equation of a line. Now x0 is 0, y0 is y0, y0 minus y0 equal to dy by dx x. Okay, so this is how we deduce the line equation in 2D. Any line equation is y equal to dy by dx into x, more or less. Or if I'm taking a curve, then any point, the line equation, any point, because every point, the tangent would be different at any point. If it is really a line, every point line equation will be same. But if it is a curve, then every point line equation will be different because it will be tangent. But at that point, what is the line equation? Dy by dx at that point, at that x point into x. Oh, okay, this much we understood. What about z? Now, consider this is x-axis, this is x-axis, this is y-axis, this is xy plane, this is x-axis, this is x-axis, this is y-axis, this is x-axis, this is y-axis, this is z-axis, this is xy plane. If this is xy plane, this surface is kept on the xy plane. Now surface I tilted like this. If surface I am tilting like this, then what is the equation of z? Y is same. This is x-axis and this is y-axis. Okay. Now y I kept like same. X-axis I tilted like this. How much? Now this is here z equal to 0. This is kept at xy plane. Z equal to 0. Height is 0. If I tilt like this, how much height it went up? Now this is x-axis. At any point x on the x-axis, what is the height z? This is x-axis. This is point x. This is height z. How much height z it has achieved where the below the x on x-axis point x? How much angle you have tilted? Anyone will say. Okay, I can tell you the slope. What is the slope? What is the slope? Slope is dz by dx. Dz by dx is the slope. But slope will be constant all the while because it's a straight line. It's a straight surface. So The height z is nothing but dz by dx into x. If this is x-axis and this is how plane is like this, then this height, that is z, is dz by dx into x is the z. Okay. Now I am shifting. Now this is this is this is point x. This is point x, and at point x height is z. Okay. Now I am shifting y also. Earlier I kept y constant, x-axis y constant. I tilted x-axis. Now x is constant. I'm keeping x constant and tilting y. Now if I'm tilting y, then at any point from origin, any point y, how much is the height? dz by dy into y. So at any point x comma y, what is the height? If I keep y constant and push x-axis up at any point x, what is the height? Height z equal to dz by dx into x. Okay, dz by dx is constant here. Otherwise, dz by dx at any point where I'm trying to calculate the z. If I am trying to calculate z at point x0, then it is dz by dx calculated at x equal to x0 into x. That is the equation of the line. Now, if this is kept on xy plane, x-axis is constant, I'm shifting only y. At any point y, what is the z? Then at any point y equal to y0, what is the z? Z is equal to dz by dy at y equal to y0 into y. That is the equation of this line. Now I have any point on the surface is x0, y0, x0, comma y0. Then point name is x0, y0. Anyone can take any point, alpha, comma, beta, x1, y1, whatever. x0, y0. Now, if I tilt it like this, keeping y constant and then keeping x constant, I tilt it like this. Now, if I tilt it like this, I have dz by dx. And then keeping x constant, if I tilt like this, then I have dz by dy. What is the z height at point x0, y0? Okay, that can you, if you see very meticulously, very closely, then if I keep y constant, if I raise z value height, then it is raised. If I keep x constant and y variable, then it is going even up. Looks like whatever z was achieved by lifting the x and whatever zy achieved. Now consider that this is kept on xy plane. If I lift only y, then it goes to some height. Okay, consider that height is beta. Now I keep y constant and lift like this, then it went to a height called alpha. Height is alpha and height is beta when one is kept constant. So height is beta when height is beta when zx is kept constant. When height is alpha when y is kept constant. So at any point x0, y0, x0, y0, if I just take y0 point, keep xy plane on xy plane, keep this surface on xy plane, and then I keep x-axis constant, I tilt it up. If I tilt it up, then z is going up by beta. Okay, beta at if this point is origin, at point y0, z went up by beta. Now again parallel. Now keeping y constant, if I keep like this, then at point x0 height is alpha. At point x0 height is alpha. Now I do both. So at point y0 height is beta. At point x0 height is alpha. At point y0 if I shift it, the slope is dz by dy at y equal to y0. If I shift like this, then dz by the slope is dz by dx at x equal to x0. Now I do both. Okay, I do both. Now keeping y constant, I move like this so that dz by dx is same at x0. So height is alpha at x equal to x0. Keeping x constant, I move like this. Now z is moving up even up. Now this is the situation when I move both. In that situation, x at x0, y0 point, what is the height? At x0, y0 point is the height is summation of both. That is alpha plus beta. Anyone can try. Okay, so what is z value? Z equal to nothing but dz by dx when x equal to x0 into x plus equation of z plus dz by dy when y equal to y0 into y. Because we are adding it, right? First keeping y constant, then height, keeping x constant, then height. Height is growing. So height is getting added up if I keep one constant. So if I do like this, if I just lift the x-axis keeping y constant, then dz by dy is 0. In that sense, equation of the surface is z equal to dz by dx at x equal to x0 into x. If I do like this, keeping x constant, then surface equation is dz by z equal to dz by dy at y equal to y0 into y. Now, if I do both, keeping one constant and keeping other constant, then summation of this, then z equal to dz by dx at x equal to x0 into x plus dz by dy at y equal to y0 into y. So surface equation of any surface that is a flat surface is z equal to fxy equal to dz by dx. Okay, I'm not going to say x equal to x0. I believe it is all right. It is understandable because surface area of a flat surface is dz by dx into x, z equal to dz by dx into x plus dz by dy into y. Okay, this much we got. Z equal to fxy equal to dfxy by dx into x plus dfxy by dy into y. Okay, now let's see the Taylor series in 2D fxy equal to y. First order. First order is fx equal to dy by dx into x. Fx equal to dy by dx into x, where only one independent component is x. Now here fx equal to fx equal to dfx by dx into x. Here fxy equal to first order dfxy by dx into x plus dfxy by dy into y. How they are related to each other? They are very much related to each other. One has independent component at x-axis, other has two independent component is x and y. Let's consider there is only one independent component, that is xy plane. Okay, what is the equation of the surface? What is the equation of the surface? Sorry, what is equation of the surface when independent component is only xy plane, not x-axis and y-axis? That is the question. So if I say my independent component is x only, then fx equal to dfxy by dx into x. Now, if I say my independent component is xy plane, then I can say fxy equal to dfxy by dxy plane into xy plane, means xy axis. Same, right? dfx equal to dfx by dx into x. fxy equal to dfxy by dxy plane into dxy plane into xy plane. Same thing, right? Now question is arising, what is equal? If I say x-axis, then for x-axis I introduce a symbol called x. What about symbol I need to produce there in the synonym of xy plane? That is a question mark. But I know the result. dfxy by dxy plane into xy plane is nothing but dz by dfxy by dx into x plus dfxy by dy into y. Answer I know, but how I can transform x into xy plane? Let's try keeping x at x plus y. Now consider that I have a polynomial equation. If you remember how we proved the Taylor series in two dimensions. If I proving the Taylor series or Maclaurin series, I consider a well-behaved polynomial equation. Well-behaved polynomial equation fx equal to a0 plus a1x plus a2x square plus plus a3x to the power 3 plus an x to the power n. This is a well-behaved polynomial equation. I try to replicate this polynomial equation into gx where I was trying to capture only differential every order derivative. In that sense, first I calculated fx when x equal to 0 or in Taylor series x equal to x0. So if x equal to 0 if I take for simple, then fx equal to a0. Fx equal to a0. Now, if I do dy by dfx by dx at x equal to 0, then dfx by dx equal to a0 gone. Then a1, only a1. So a1 equal to dfx by dx when x equal to 0. d2 fx by dx square equal to a0 gone, a1 gone. Now 2 into a2, 2 into a2. So a2 equal to d2 fx by dx square into 1 by 2. What is d3 fx by dx cube? First 3 gone, and now 3 into 2, 3 into 2, a3, that's it, plus whatever. So if I set x equal to 0, all would go away. So in that sense, then d3 fx by dx cube equal to 3 into 2 into a3 plus all gone when x equal to 0. a3 equal to 1 by 3 into 2 or 1 by factorial of 3 into d3 fx by dx cube. Can we find same thing? But here independent component is x. What is equivalent of x in xy plane? If I just take xy plane, not x plus, not x axis and y axis separately. Let's try with x plus y. Replace x with x plus y and let's see if it comes, because one result I have, right? fxy equal to dfxy by dx plus dx into x plus dfxy by dy into y. One result I have. Let's try matching it. Now let's consider I have a well-behaved polynomial equation fxy equal to a0 plus a1 and in bracket x plus y, okay, plus a2 in bracket x plus y whole square. I am replacing x with x plus y. Let's try. Okay, first I'll try fxy when x equal to 0 and y equal to 0. That is a0. Okay, done. What about dfxy by dxy by dx when x equal to 0, x equal to 0 and y equal to 0. Now first a0 gone, first difference is. Next is a1x plus a2x, a1x plus a1y. So a1 and a1 by y is gone. Onwards gone because x equal to 0, y equal to 0. So a1 equal to dfxy by dx. What about dfxy by dy? Again a1. Okay. If that is the case, again a1 when x equal to 0, y equal to 0. So if that is the case, then a1 equal to dfxy by dx and a1 equal to dfxy by dy, where we have a1x plus a2y. The fxy we have taken, a well-behaved polynomial equation we have taken, we replaced x with x plus 1. This is also a multivariable polynomial equation. fxy equal to a0, this is our assumption. fxy equal to a0 plus a1 in bracket x plus y plus a2 in bracket x plus y whole square in bracket like that an x plus y to the power n. Now if I take first derivative and get the value at x equal to 0, y equal to 0, then fxy, the fxy is first order derivative. So fxy originally it is a0 plus a1x plus a1y plus a2 x plus y whole square plus a3 x plus y to the power 3 like that. First is a1 ax plus y or a1 x plus a1 y. Now a1 equal to dfxy by dx first term and other a1 is dfxy by dy. Looks like first order is dfxy, first order is dfxy by dfx, the fxy, the first order. Now the first fxy, the a1, the formula of, if you see the single, if you see the two dimension, then a1 I replace b simply by dfxy by dx, then it becomes dfxy by dx into x. Now a1, first a1 I have to replace with dfxy by dx. Next a1 I have to replace with dfxy by dy. Now it becomes fxy becomes a0 plus dfxy by dx into x plus dfxy by dy into y. Is it not the same exactly what we deduced? Fxy equal to dfxy by dx into x plus dfxy by dy into y. Is it? It is exactly same. Looks like the xy plane what we have to take to replace x in two dimensions is x plus y. Someone can try anything. Someone can try replacing x and x into y. If someone replaces x into y, then dfxy by dx, then x into y, then it is a0 plus a1 x into y. If someone tries this, then dfxy by dx equal to, okay, equal to a1 into y, a1 into y. If substitute x equal to 0, y equal to 0, everything becomes 0. a1, what is value of a1? No one knows. So replacement of x for the xy, single xy plane independent variable is not possible if xy plane is x into y. Anything someone can try. It fits. I don't know how, I don't care how what it would be, but it fits in when x is replaced with x plus y. Let's try other thing also. Now I know that the fxy, the Taylor series approximation for the fxy equal to a0 plus a1 x plus y plus a2 x plus y whole square. This one we are trying now. So multivariable case. Now let's try dual differentiation. Now I have a2 x plus y whole square, that is a2 x square plus 2a2 x into y plus a2y whole square, d2fxy by dx square. First two term gone. Now next is a2 x square, that becomes 2a2 other gone. Okay, and if you set all higher thing, if you set x equal to 0, y equal to 0, all will go away. Now a2 equal to 1 by 2 d2 fxy by dx square. Now let's try again. dfxy by dx into dfxy by dy. Let's try this. Now we will proceed. If I then first a0 a1, if I do dual differentiation, one in x and one in y, first two term gone. Other is a1 x square. First differentiation dfxy by dx is alright. Next differentiation with y means that is also gone. Okay. Then next is 2xy. 2xy, first differentiation with x results in 2y. Next differentiation with y results in 2. Okay. Now it is a2 into 2. So a2 equal to 1 by 2 dfxy by dx into dfxy by dy. Understandable? Now let's, other will be 0. Now let's write d2fxy by dy square. Now a2x square gone, 2xy gone, y square, that is a2y square. Now it becomes 2a2. Rest is gone when x equal to 0, y equal to 0. If that is the fundamental, then a2 equal to d2 fxy by dy square. Now assemble it as per the what we have calculated. Now the fxy equal to a0 plus dfxy by dx into x plus dfxy by dy into y. Now next term is a2. Okay, so a2x square. So a2 is 1 by 2 d2 fxy by dx square into x square plus 2xy. a2 2xy. a2 is 1 by 2 d2 dfxy by dx into dfxy by dy into 2xy 2 gone. Now it is dfxy by dx into dfxy by dy into x into y plus a2 y square. Now a2 is 1 by 2 d2fxy by dy square into y square. Now someone can try a3 and x plus y whole square x plus y to the power 3. Break it and do triple differentiation d3fxy by dx cube, d3fxy by dy cube, and d2fxy by dx square. Anyway, we have that, we have to try here. d2fxy by dx square into dfxy by dy and dfxy by dx into d2fxy by dy square. So then A3 will be resolved. Whatever comes, that is just keep, because if the way we are reproducing any case, we are replacing A0, A1, A2, A3, A4 with differentiation, and then we get Taylor series. So this is the multivariable Taylor series or Maclaurin series through us. So what we need to do is first order derivative we proved by the algebra, and that is the proved case. That we know that fxy equal to dfxy by dx into x plus dfxy by dy into y as per the algebra, like y equal to dy by dx into x. Similarly, as per algebra, this is the equation. If that is the equation, then we found that if in 2D fxy equal to y, in 2D where x is independent component, not xy, there if I have Taylor series, everywhere x I replace with x plus y. Now independent component instead of x. Now for multivariable, I am keeping independent component as xy plane, single independent component, xy plane, not x axis. If that's why I say to solve mathematics, try to cornering the case, make things smaller, then tackle it. Now if I go with simple xy plane, then what is equivalent of x axis to the xy plane in the 3D? We saw it is x plus y. Now replace everywhere x with x plus y and then proceed and then substitute a1, a2, a3, a4, whatever comes through the differentiation, and you get the multivariable Taylor series for polynomial. This is our proof, the simplest of the simplest. Please do support us. +91 is the India country code 9483160610. +91 is the India country code 9483160610. Okay, what is next? Someone can try multivariable case when independent variable is x, y, and z. Now it is pretty simple. Instead of x, just replace it with x plus y plus z. Okay, and you get the Taylor series for the multivariable case where independent component is x, y, z. We will try doing that for some case, but on pen and paper anyone can do for the higher order also. Please do support.